Hi guys, welcome to the Instructive Academy. So today we are going to study about the periodic table. How was the periodic table born? At a point, a need arose to group elements such as metals, non-metals, transition elements, and even noble gases into families whose elements showed maximum resemblance. So a scientist named as Mendeleev had arranged elements in the periodic table on basis of increasing atomic weights. But something did not work. So Moseley modified Mendeleev's periodic table and stated that the basis of classification of elements be according to the increasing atomic numbers and not the atomic weights, since the physical and the chemical properties of the elements depend on the number of electrons and their arrangements. So the basis of classification of elements was done according to the atomic number and not the atomic weight. Why? Because the physical and the chemical properties of the elements depends on the number of electrons and their arrangements. Now, what is atomic number? Atomic number is equal to the number of electrons in the energy shells of an atom. Hence, it is called the fundamental property of an element. So, the arrangement of the elements in the periodic table is thus based on the modern periodic law, which states that the physical and chemical properties of elements are periodic functions of their atomic number. So there are some salient features of the modern periodic table. Starting with the first one, the periodic table is based on one fundamental property, that is the atomic number. Second one, the position of the elements depends upon the electronic configuration. Now, what exactly do you mean by electronic configuration? It's the distributions of electrons of an atom or a molecule in atomic or a molecular orbital. The arrangement of the elements in the periodic table is in the increasing order of their atomic numbers. Increasing order of their atomic numbers. For example, if you see in the periodic table, hydrogen has the atomic number of 1, helium has the atomic number of 2, lithium is 3, beryllium is 4, boron is 5, and so on. There are 7 horizontal rows called periods and 18 vertical columns called groups. The period begins with an element having 1 electron in the outermost shell and ends with a 0 group element having completely filled outer shell. For example, if you look at period 2, the element lithium with an atomic number 3 has only 1 electron in the outermost shell and if you look at neon, which is the last element of period 2, has a completely filled outermost shells with 8 electrons. Thus, in the periods, a transition from metallic to non-metallic character is seen across a period. For example, on the leftmost side, we have lithium and beryllium as metals, and when we come to the right side, we have boron, carbon, nitrogen, oxygen, fluorine, neon as non-metals, out of which the fluorine is a halogen and neon is a noble gas. Each vertical column, that is a group, accommodates elements with the same outermost electronic configuration, hence it has same properties. Or we can say that those elements have similar properties. For example, if you look at group 2, the element beryllium with an atomic number 4 has 2 electrons in the outermost shell, and as we go down in the group, the element magnesium with atomic number 12 also has 2 electrons in the outermost shell. So it goes like 2 elements in the first shell, 8 which is the maximum electron count in the second shell, and the last shell comprises of 2 electrons, and that gives us the atomic number of 12. So this shows that as we go down the group, the outermost electronic configuration will remain the same. So groups 1, 2 and 13 to 17, that is 1A to 7A, are called the normal elements. Group 3 to 12, that is 1B to 7B and 8, are called transition elements, and group 18, that is 0, they are also known as the 0 group, at the extreme right in the periodic table, contains the noble or the inert gases. Now the separation of elements is done in this way. The reactive metals are placed in group 1 and 2. The transition elements, which are also metals, they are placed in the middle, that is from group 3 to 12 as we had seen here, and the non-metals are placed at the upper right corner. Now let's see the gradual change in the properties. How is that seen? The gradual change in the property is seen with the increase in the atomic number in the periodic table. The reoccurrence in the properties or the similar properties are seen with the elements belonging to the same subgroup in the periodic table. For example, if we take the group 18, they are all of noble gases. Suppose helium, neon, krypton, xenon. These all are in the same group, so they will have similar properties. And one of the most important property of this group or the noble gases is that it's the least reactive, and that's why they are known as the inert or the noble gases. So before we come to how an element is read in the periodic table, I would like to tell you something about the inner transition elements. Those occur in the period 6 and period 7. So in the period 6 we have something called a lanthanide series. Those are the rare earth elements. And in period 7 we have something called as the actinide series. Those are the radioactive elements. We will learn about these elements in the later videos. Now coming to how an element is read in the periodic table. Here I have drawn the key of beryllium. So here at the leftmost corner we have the atomic number, which is 4. Then the symbol of the element is given in the middle. The name of the element is given below the symbol, and the relative atomic mass is given at the bottom. So this is the way you have to read any key element in the periodic table. So this was all about the fundamentals of the periodic table. In the next videos, we will dive more into the chapters wherein we'll be learning more about the elements and their properties according to the groups and periods. So stay tuned, and if you like the video, please turn the black thumb blue and do subscribe to our channel. Thank you.